Hello guys, this is Dev. Today I will continue with the part 4 of the MCQ series, okay? So let's start. So this is the first question. It is written, the upper half of an inclined plane of inclination theta is perfectly smooth. Okay, you should read the question very carefully. It is written, the upper half of the plane is smooth, while the lower half is rough. Okay, this means the lower half of the plane has some friction. A block starting from rest at the top of the plane will come to rest at the bottom. If the coefficient of friction between block and lower half is, for example, mu, then we have to calculate the value of mu. Okay, these are the values written. All right, let's see. All right, so this is the figure. Okay, so you see the friction only acts on the half part of the inclined plane. All right, so when the block has descended half of the distance, then the friction acts. Okay, so since friction, as I earlier told you, is non-conservative, alright, since friction is non-conservative, this means that Ke plus U would not be constant, alright. Since in case of conservative forces only, like gravity, the total mechanical energy is constant, alright. Or we can say the change in kinetic equal to negative change in potential. But this does not apply here because friction is acting. So this means we will apply the basic equation, which is the change in kinetic energy is the total work done. Alright, this is the basic equation which works everywhere whether the force is conservative or not. So the block starts from rest and ends at rest. This means the change in kinetic energy is 0. Now what is the total work done? Obviously work is done by force, right? What are the forces? This is one force, gravity. Alright, gravity, the component of gravity is doing the work, because component of gravity is dragging the block along the plane, and the other component is balanced by normal. So normal is not doing any work. Okay, n equal to mg cos theta, and gravity is mg sin theta. So gravity will act for the whole of the distance, alright, for the whole s. So the work done by gravity would be mg sin theta times s. But after half distance, friction will come into play. So friction will do a negative work on the block for half of the distance. So this means this would be minus mu mg cos theta s by 2. This is because frictional force would be directed away, or we can say, anti-parallel to the gravity. And friction is mu times n. So n is mg cos theta. Okay. So we can take out s. Okay, s will not be 0, only this expression will be 0. Mg sin theta equal to mu mg by 2 cos theta. So mu is, what is mu over here? Mg gets cancelled out, mu is 2 tan theta. Alright, so we have our answer 2 tan theta. Okay, 2 tan theta is the answer. So option 3 is my answer. Okay, mu equal to 2 tan theta. This is the answer. Alright, so moving on, we have an explosion breaks a rock into 3 parts in a horizontal plane. Mind it, the explosion is in horizontal plane. 2 of them go off at right angles to each other. Okay, and the first part of mass 1 kg moves with the speed of 12 meter per second, and the second part of mass 2 kg moves with 8 meter per second. So these are the two which have gone at right angles to each other. If the third part flies off with 4 meters per second speed, then mass is, we have to calculate the mass of this third part. Okay, so we have this figure. We see that m1 and m2 have flown off at right angles to each other. Let us assume that m3 flies off this way at an angle phi. Alright, so we are given these parameters. We have to find out m3. How do we do it? You see, first of all, there is no external force, only forces are internal. Okay, since forces are internal, they cancel out and momentum remains constant, because force equal to 0, F net is 0, there is no external force here. So dp by dt is F net, which is 0, so P net equal to constant. So since this vector is constant actually, alright, this means that the momentum when resolved will be constant. You see, when we resolve this momentum, we see that this momentum these are the three momentum. This is P2, this is P1 and this is P3. I am resolving P3. We have P3 cos phi and along this we have P3 sin phi. So along x-axis, what is net momentum? X-axis along we have the net momentum. You see this P net is constant, okay? So this means that the net momentum initial momentum equal to final momentum. Alright. Because since P is constant, delta P would be 0. So we see that initial momentum was 0. Final momentum, what would be the final momentum? If this is I and this is J, what is the final momentum? Final momentum would be P2 minus P3 cos phi I plus P1 minus P3 sin phi J. Alright, since this is 0, so we can equate these two individual terms to be 0. So we have P2 equal to P3 cos phi and we have P1 equal to P3 sin phi. So squaring and adding, we get P3 equal to root under P1 square plus P2 square. Okay, so we can easily find out M3 from here. We see what is P1. P1 is 12. What is P2? P2 is 16. Okay, M2 V2. So 12 square would be 144. 16 square is 256, right? So this would be 400. So root under of this would be 20. This is equal to P3. What is P3? 4 times M3. This would be equal to 20. So this cancels out. M3 equal to 5. M3 is 5 kg. This is the answer. Okay. Alright. So the second option is my answer. M3 equal to 5 kg. Okay. Alright. So we move on to the next question. It is written a rod of PQ of mass M and length L is hinged at end P. The rod is kept horizontal by a massless string. Okay, this string is massless, tied to a point Q as shown in the figure. When the string is cut, the initial angular acceleration of rod we have to find. Okay, so this is the rod of mass M, length L, and these are the four options. Okay, so this is the figure. You see the rod is first attached to a string at Q and this is the hinge at P. Okay. So when the string is cut, the rod will move like this. Okay, so the rod will rotate about P. Rod will rotate about P. Alright. So rotation is happening about P. Hence, there must be some force which is applying a torque about P so that the rod is rotating. That force is the weight. Okay, weight is applying a torque about the point P. So this is L by 2 since the weight is at the center and P is the other end of the rod. So the torque at P would be equal to mg L by 2. Alright. And the torque is, as all of you know, torque is I alpha. Alright, I is the moment of inertia about the point of rotation. Hence, moment of inertia about point P we have to take. So what is the moment of inertia about the end of the rod? I have already explained it. So it is ml square by 3. Okay. So ml square by 3. I have explained it in my previous videos. You can watch it. mgl by 2. Alright. So L goes and we have to calculate alpha. M also goes away. So alpha is equal to 3g by 2L. Alright, so this is the answer. Alpha equal to 3g over 2L. So here A is my answer. Okay, 1. This is 3g by 2L. So the first option becomes my answer. Okay. Alright, so moving on, we have infinite number of bodies, each of mass 2 kg situated on the x-axis at a distance 1 meter, 2 meter, 4 meter, 8 meter respectively from the origin. We have to find out the resulting gravitational potential due to this system at the origin. Alright, so this is the figure. You see, this is the origin and these are the masses. Masses are same 2 kg, 2 kg, 2 kg and this goes on till infinite. Okay. First mass is at a distance 1 meter, second is at 2 and third is at 4 and fourth is at 8. Okay. So we have to find the potential. First of all, I want to recall you that potential is V equal to minus Gm by R. Okay. I have derived this in my earlier videos. Please go and see them and you will get to know how to derive this and what is it about. Okay. So we have to find the net potential at origin. Okay, so this 1 meter is 1 meter from the origin, this 2 meter is 2 meter from the origin, and this 4 is from the origin. Okay, so we are to add up the potential, because potential is scalar. Potential is a scalar quantity. To find the net of the scalar, you just add it. Okay, so potential due to this mass would be minus 2g by 1. Potential due to this mass would be minus 2g by 2. Potential due to this mass would be minus 2g by 4. Due to this would be minus 2g by 8, and go so on. Okay, it will go. So this is V. So V would be equal to minus 2g into 1 plus half plus 1 over 4 plus 1 over 8 plus dot 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 infinite. Okay. So this is a GP, geometric progression. Okay. So in an infinite geometric progression, the only answer to the sum is A upon 1 minus R, as I know. A is this and R is R actually is the second term divided by the first. So half is R. Okay. So this means minus 2g times A is 1 upon 1 minus R is half. So this would be equal to minus 4g. Okay. So the net potential at the origin is minus 4g. Okay. This is the answer. Okay. So the fourth option is my answer, minus 4g. Alright. Alright. So moving on, a wave traveling in the positive x direction. Okay. Having displacement along y direction as 1 meter. Okay, wavelength is given as 2 pi meter and frequency 1 over pi hertz. Okay, is represented by. So we have to calculate the equation of wave. Alright. Okay, so these are the parameters given. We have to find out the equation of wave. So generally wave equation is kind of like this: A sine kx plus minus omega t. Okay, this is the wave equation for y versus x. What is A is the amplitude. Here 1 meter is the amplitude. Okay, because the maximum displacement of y is given. Okay, so here y can be sine kx plus minus omega t. We have to find out what is k here. K is 2 pi by lambda. This is known as wave vector. Okay, this is known as wave vector. It indicates the direction of wave, direction of propagation of wave. Alright, and omega, as all we know, omega is the radial frequency and omega is 2 pi f. F is the normal frequency. Okay, so how do we know that the wave is traveling in the positive or negative direction? You see, the equation of wave is written as y equal to amplitude times sine, and in the sine we write the phase. This term kx plus minus omega t is known as the phase of the wave. Alright, generally we keep the phase constant. Okay, wave as a constant phase. So what happens is, for example, if I take kx plus omega t, y equal to sine of kx plus omega t is the wave. Now how do I know whether it's traveling in the positive or negative? What we do is kx plus omega t would be constant. Alright, for a particular x and a particular y, this phase would be constant. Alright, so I now differentiate this for a particular x and particular y. Okay, so we will keep this phase constant for particular x and y. So now I differentiate this. What we have here is dx with respect to time. So we have k dx by dt plus omega should be equal to 0. Dx by dt here will indicate the velocity of wave. Okay, velocity means v vector, so it has a direction. Okay, so v vector is minus omega by k. This means if I am plotting wave as this, like this, and this is y, this is x, so wave is not propagating in the positive x direction. Since v is minus omega by k, this means wave is propagating in the negative direction. So this means kx plus omega t, if I write, then wave is propagating in the negative direction. So for positive I have to write kx minus omega t. Since for a particular x and y and t this is constant, so now I differentiate this. We get k dx by dt equal to omega. So v vector is now omega by k. This means this is in the positive direction. Okay, so I now have kx minus omega t. So the equation right now we have y equal to sine kx minus omega t. Okay, so now we have established that minus has to come. Now what is k? K is 2 pi by lambda. Lambda is the wavelength, which is 2 pi. Okay, you see the wavelength is the distance between successive crest or troughs. Alright, this means you cannot take the wavelength as distance between one crest and one trough. No, the wavelength is the distance between successive crest or successive troughs. Okay, so 2 pi by lambda is 2 pi by 2 pi, which is equal to 1. Omega is 2 pi f, which is equal to 2. So my equation now becomes y equal to sine, what is k? K is 1. So x minus omega is 2. So x minus 2t. This is my answer. Alright. This is my answer, y equal to sine x minus 2t. So option 1 here is my answer, y equal to sine x minus 2t. Okay. Okay, so moving on, we have a system consists of 3 masses m1, m2, m3 connected by strings passing over the pulley P. Okay, this is the pulley P. Mass m1 hangs down freely and mass m2, m3 are on rough horizontal table. Okay, this means this table has a friction over here. There is no table which is attached to mass m1. Okay, coefficient of friction is assumed as it is written mu. It is written u over here. I am assuming mu. Okay, the pulley is frictionless and negligible mass. You see, the pulley is frictionless and of negligible mass. As I told you earlier, pulley should be massless. The downward acceleration of the mass m1 is, so we have to find out the downward acceleration of mass m1. Here the coefficient of friction of the surface is mu and all the masses are assumed to be same. Okay. Okay, so this is the figure. The table has a friction mu coefficient and all the masses are same. Okay, m1 equal to m2 equal to m3. Alright, this is given as m. So I want to find out the acceleration of m1. You see, since the string is tied and the masses are tied and there is no other external force, the acceleration of all the masses will be same. Alright, so let us assume, the string's length. This is, L1. This is L2 and this is L3. Alright. So the mass m1 descends some distance. Okay, let us say this is x1. Alright. Let us say this is x1 and the mass m2 will also move forward with x2. Okay. The length of this string going on over the pulley between mass m1 and m2 is L1 plus L2. Okay, this is the length of the original string going between m1 and m2. Now when the mass m1 has descended a distance x, string has descended with the mass. Hence this string has moved forward. So now the new length would be, you see the new length would be, what will be the new length? The new length would be, since it has descended x, so x1 plus this would be L1 minus x. Okay, so this would be L1 minus x1 plus L2 minus x2. This would be the new length, L original. Okay, sorry, L new. Okay, L1 minus x1 plus L2 minus x2. Since this has moved forward, so this distance would be now this. This would be L2 minus x2 and this has moved down, so this would be L1 plus x1 actually. This would be L1 plus x1, yeah. Since the string will now be from here pulley to till this mass, so L1 plus x1 plus L2 minus x2. Okay, this would be the new length. Now the new length of the string is equal to the original length of the string because the string is inextensible. Okay, string does not extend and is not flexible. Okay, so L original equal to L new. So this gives us L1 plus x1 plus L2 minus x2. This would be equal to L1 plus L2. This cancels out. So we have x1 equal to x2. Hence the double differential d square x1 by dt square equal to d2 x2 by dt square. So a1 equal to a2. This I have established. Okay. So the acceleration of m1 equal to acceleration of m2. This we have established. Now let us see for m2 and m3. You see this is m2 and this is m3. Alright. So now the length of string between these two, let us say this is L3. Okay. So when this moves forward, so let us say this moves forward a distance, x2, and this will also move forward a distance x3. Okay. So now the new length, what will be the new length? The new length would be x2, L2 plus x2 plus L2 plus x2 minus x3. This would be, sorry, this is L3. L3 plus x2 minus x3. This will be the new length. Original length was L3 and new length is also L3. Why? This is because this string is also inextensible. This string is also not flexible. Okay, it is not stretchable. So the length will remain same despite the masses being displaced. So the new length of the string will be L3 plus x2 minus x3, and the new length will be equal to the original length. So L3 L gets cancelled out. So x2 equal to x3. Alright. So the double differential of x2 will also be equal to x3. Alright. So this means a2 equal to a3. Hence a1 equal to a2, a2 equal to a3. So we have established a1 equal to a2 equal to a3. Okay. Nobody does this, but I am doing this just to clear your concepts, so that you have a clear understanding why accelerations are equal. I will also do some questions where accelerations are not equal. Alright, to give you a basic crisp of the concepts, I am doing this. Otherwise, anyone can solve this question. It is just a cakewalk. Okay. Now, alright, so acceleration of all the masses are same, we have established. So now we will find out the equation of motion. First I take the mass m1. You see, if you want to draw the free body diagram, first you have to free the body. Okay. This is m1. What are the forces on m1? First is gravity. The other is tension due to spring. Okay. String. So you see, the string is common. Okay. From here to here the string is common. So the tension will be same. Okay, as string is massless. Alright. So what is the equation of motion of this mass? Would be m1g minus t equal to m1a. Alright. What is the equation of motion of m2? M2 has t over here, and this is another string. Okay, this is not the same string because a block is there between. So this will be different tension, t dash m2. Okay. So this would be t minus t dash, and there is a friction force over here. So F. Okay. And F is equal to mu into normal. Normal would be equal to m2g. So these are the forces on m2. So t minus t dash minus F equal to m2a. A is same as I have done it earlier. F would be equal to mu times n. N is m2g. So here m2g. Okay. This is F2. Friction force on the block 2. Alright. Now on 3 if we see, only t dash is acting and friction is acting. So this would be t dash minus F equal to m3a. As m1, m2, m3 are same, this is F3. So you see F2 was mu m2g. So this would be mu mg if I assume m1, m2 and m3 equal to m. So this equation would be mg minus t equal to ma. F2 would be equal to mu mg. This would also be equal to F3, which would also be mu mg. This would be the first equation. Next equation would be t minus t dash minus mu mg equal to ma. Last equation would be t dash minus mu mg equal to ma. Okay, I have assumed m1 equal to m2 equal to m3 equal to m. Alright, as given in the question. So just add all of these. You see t dash and t gets cancelled. This is second, this is third equation. I am adding all three. This also gets cancelled. So we have mg minus 2 mu mg equal to 3 ma. Mm gets cancelled. I have to find a. So a would be equal to 1 minus 2 mu times g by 3. This is the answer. Okay. The acceleration is equal to g times 1 minus 2 mu by 3. Okay. This is the final answer. Okay, so third option is my answer, g times 1 minus 2 mu the whole divided by 3. Okay. Alright, so let's move on to our next question. It is written, a balloon with a mass m descending down with an acceleration a. Here it is given that a is less than g. Okay. How much mass should be removed from it so that it starts moving up with an acceleration a? Okay, initially it was going down. Now we have to remove some mass so that it goes up with the same acceleration. Okay. These are the four options given. So we have to calculate how much mass should be removed. Alright, so this is the figure. You see, we have the balloon over here and mass m, and it is going down with acceleration a. You see, it is given that acceleration a is less than g. This means that there must be some force, okay, which is decelerating the mass, because if there was no force, then acceleration a would have been equal to g. But this is not the case over here. A is less than g. This means there must be some upward force. Okay, we can say this force is the force due to the thrust of the engine, which heats the balloon and heats the helium gas and makes the balloon go up. Okay, we can say this is the internal force F. So we see, because air resistance is not given over here. Air resistance is not given. So this force must be some force inside the balloon which makes the balloon go up. Okay. So what is the equation of motion in this scenario? In this scenario, forces on mass m are mg and f. This means mg minus f equal to ma. This is because m is coming down. Now if we remove mass, let us say I remove delta m. This means the mass left over is m minus delta m. It goes up. Alright. In this case also, the force which is driving the balloon up is constant force F. Okay, I have assumed this. And this is the gravitational force, m minus delta m times g. So what is the equation of motion over here? Since it is going up, this means this for equation of motion is F minus m minus delta m g equal to m minus delta m times a. Okay. Now I just add. This cancels out, mg cancel out. This means delta mg equal to 2 ma minus delta ma. So delta m is 2 ma upon a plus g. Okay, this is my answer. This is the answer for the mass which I have to reduce so that the balloon goes up with the same acceleration a. Okay. Alright, so option 1 here is my answer. 2 ma upon g plus a. It is not written appropriately. Okay, it is g plus a and 2 ma upon g plus a. Alright guys, I'm stopping here. In the next video, we will go through simple harmonic motion. Okay, from the very basic to very advanced. Okay, please like, rate, review, subscribe. Thank you very much.